Hey Titans, it's Mr. Spilker here. Hello and welcome to the Chapter 10 final review. Here I'm going to take you through questions from Chapter 10 that you might see on your final exam. Keep in mind your final exam is coming on Tuesday and Wednesday of next week. Dr. Spilker has prescribed studying each and every day. Make sure you follow my prescription for success. So go ahead and have the heading on your paper be Chapter 10 Final Review Notes, and we'll go ahead and get into our first example. All right, example number 1. What are the zeros of the function that is graphed? So go ahead and look at that graph and decide what are the zeros. Well, we can tell the zeros just by looking at the graph, because the definition of a zero is where the graph crosses the x-axis. So if you look at the graph here, it crosses the x-axis at 1 and 5. So my zeros are 1 and 5. The second question in dealing with that graph is, what is the equation? Well, if we look at that graph, we can identify the vertex. The vertex of that graph is the ordered pair 3, -4. Now, if you remember parabolas, we had vertex form, which was y equals x minus h squared plus k, where hk was your vertex. So in this case, to write our equation, we'd have y equals x minus 3 squared minus 4. That would be the correct equation for the graph above. Notice I took the vertex 3, -4, and I plugged it in to the vertex form of the equation. Now sometimes students will look at that and say, hey, Mr. Spilker, you made a mistake. And my response is, I don't make mistakes. A lot of people point to the fact, well, hey, wait a minute, you have a -3, and shouldn't it be a +3? And my response to that is no. If you remember correctly, inside the parentheses, it's always opposite for x, same for y. Opposite for x, same for y. And remember, we remembered that by saying apotaco for x, same for y. So your vertex is 3, -4. So make sure you have something about those two examples down in your notes. You might want to have something about the zeros being where the graph crosses the x-axis, and then something about vertex form and plugging in the vertex. So those are your first two examples for the Chapter 10 final exam review. Let's go ahead and jump into a couple more examples. All right, the next part of our final exam review here in Chapter 10 is going to be solving some equations. And the first method that we are going to practice here in our Chapter 10 final review is the square root method. Solve by taking square roots. So in this first example, I'm going to go ahead and solve it by dividing both sides by 2. When I divide both sides by 2, you're left with x squared is equal to 9. Then I square root both sides, and remember, whenever I take the square root of a positive number, my answer is, I'm imagining right now that all of you just yelled plus or minus, kind of like if we were at a concert and the famous artist stopped singing, you guys would fill in the blanks. So let's try that again. The answer would be, good, plus or minus 3. Awesome. All right, go ahead and write down example number 2 here. Example number 2, same method. We're going to solve by taking square roots. So the first thing we're going to do is add 25. We want to get that 25 out of there. See you later, 25. Take a hike. Go to the other side. That leaves us with x minus 2 squared is equal to 25. Now, what do you guys think we would do next? Yes, you guessed it. Square root both sides. So when we square root both sides, we're left with x minus 2 equals plus or minus 5. Remember, whenever you take the square root of a positive number, when solving an equation, it always comes out to be plus or minus. Now, we need to go ahead and finish this off by adding 2 to both sides. And when I add 2 to both sides, over here, I'm running out of room, I have 5 plus 2 and negative 5 plus 2. So my answers are 7, and negative 5 plus 2 is negative 3. 7 and negative 3. Let's go ahead and pause the video here if you need a couple seconds to write these examples down into your notes. These are two good examples, and once again, the first equation solving method that we're practicing here is the method of taking square roots. Don't forget, students, that whenever you take the square root of a positive number, it comes out to be plus or minus. Alright, I was going to stop right here, but I think I actually heard some applause after that last example. So, as I talked about with a famous musician, a lot of applause means an encore. So, let's do a few more equations. Alright, the next method we're going to jump to is the factoring method. The factoring method. X squared minus 5x minus 14 is equal to 0. I'm going to solve this by factoring. So I take the trinomial on the left side and I factor it to be x minus 7, x plus 2. Now if you're wondering, well, why did I choose negative 7 and negative 2? I chose those two numbers because they add to negative 5 and they multiply negative 14. Remember, that's the x method. It must add to the middle and multiply to the end. After you're done factoring, your answers aren't negative 7 and 2. Remember, when you're solving by the factoring method, you must factor, split, and solve. So your answers are actually opposite of the factoring. So the first example, the two answers are 7 and negative 2. Make sure you have that written down in your notes. I'll pause here a second to make sure you have that all written down. Oop, I heard some clapping again. Let's go ahead and do another one, another encore. The next one is x squared minus 5x is equal to 6. We're going to go ahead and solve that equation by factoring method. Now you might look at this and say, wait a minute, it looks a little bit different. You are correct. We want to get it to be in standard form. So in the second example, I'm going to go ahead and take 6 and move it over. It's going to become a negative 6. Now I can solve by the factoring method. So to solve this by factoring, I would factor it. And my factoring would be x minus 6 and x plus 1. Then I split it. And I solve it. And my answers are positive 6 and negative 1. Positive 6 and negative 1 are my two solutions. Oh, I heard some more clapping. Man, you guys really like these problems. I don't want to disappoint you, so let's do a couple more. Alright, the next skill in our Chapter 10 final review is going to be working with the completing the square method. Before we get into solving by completing the square here on number 3, let's go ahead and do a couple problems here at the beginning that involve the process of completing the square. Number 1 says complete the square. In other words, we're trying to find the number that belongs on the end that would make that be what we call a perfect square trinomial. So to find that number on the end, you take the middle number, you divide it by 2, and you square it. Divide by 2 and square it. That's how you complete the square. You divide by 2 and you square it. And what number completes the square? 4. To complete the square, remember you take the middle term, you divide it by 2, and you square it. Another example that involves completing the square is taking an equation for a parabola and taking it from what we see is in standard form and put it in vertex form. To do that, you go ahead and you group the first two terms together and you leave that third term out. Then you complete the square. What number completes the square? Well, you take negative 6 divided by 2 and you square it. You add it in, you subtract it out. Then you go ahead and factor that trinomial, and you're correct, it factors to be negative 3 and negative 3. So in vertex form, you would have y equals x minus 3 squared plus 4. Let's review what we did there. We started off by grouping the first two terms together. Then with those first two terms, x squared minus 6x, we completed the square. To complete the square, we took negative 6 divided by 2 and squared it. So we got 9, so we added it in, we subtracted it out. Then from there I factored my trinomial. To factor that trinomial of x squared minus 6x plus 9, I factored it to be x minus 3, x minus 3. How does a mathematician write 2x minus 3's? Yep, you guessed it, he writes it as x minus 3 squared. And then on the outside, that 13 and 9 could simplify to be a plus 4. Now, my equation has gone from standard form to the desired vertex form. All right, the next problem here is solving by completing the square. To solve by completing the square, you go ahead and you group the first two terms together, and you complete the square. So I add in, subtract out. Here I'm going to add in a positive 16, and I'm going to subtract out a negative 16. So if I factor that correctly, it's going to be x minus 4 squared minus 36 is equal to 0. As you can see, I'm running out of room here, so let me clear some room from the work we had up above. If I then go ahead and jump up top, I'm going to have x minus 4 squared minus 36 is equal to 0. So to solve that equation, I'd move the 36 over. Then I would square root both sides, and I'd have x minus 4 equals plus or minus 6. Then I add 4 to both sides, and my answers are going to be positive 6 plus 4 and negative 6 plus 4. Positive 6 plus 4 and negative 6 plus 4. That's how to solve an equation by completing the square. All right, we got one more slide of examples, folks. Let's go ahead and jump to that here, and we'll finish this presentation strong. It is Finish Strong Friday, you know. All right, the last two of the day. The first one here is finding the discriminant. Remember, the formula for discriminant is b squared minus 4ac. b squared minus 4ac. So I would go negative 5 squared minus 4 times 3 times 2. So that's going to be 25 minus 4 times 3 is 12 times 2 is 24. 25 minus 24 is 1. So the discriminant is 1. If you remember, if the discriminant is positive, that means there's 2 solutions. If the discriminant is 0, there's 1 solution. And if the discriminant is negative, there is none. So the discriminant is a useful part of the quadratic formula because it tells us how many solutions there are to a quadratic equation. So in this case, since the discriminant was 1, that means there are 2 solutions. All right, let's jump to the last problem here, Titans. The last problem, a equals 1, b equals negative 11, and c is equal to a negative 26. Those are the 3 key values that I want to go ahead and identify so that I can plug them into the quadratic formula. Because as the directions say, we're going to solve using the quadratic formula. I'm going to go ahead and clear some space up above. So to solve using the quadratic formula, you use the formula negative b, which is going to be negative 11, plus or minus the square root of b squared plus negative 4ac all over 2a. I know that's a little bit messy, but it says negative b, which is going to end up being a positive 11, plus or minus the square root of 11 squared, which is going to be 121, plus negative 4ac is negative 4 times 1 times negative 26. Which negative 4 times a negative 26 is going to go ahead and be a positive 104. And that's going to be all over 2. So if I go ahead and simplify that even more, it's going to be 11 plus or minus the square root of 225 all over 2. Now, we know that 225 is a perfect square. The square root of 225 will go ahead and give us So we have 11 plus or minus 15 divided by 2. So 11 plus 15 is 26 divided by 2, which is 13. And then our second answer would be 11 minus 15 divided by 2, which we know is negative 2. So my answers are 13 and negative 2. All right, Titans, we appreciate you tuning in to the review for Chapter 10. We'll continue to work on Chapter 10 a little bit on Monday in our opener. And then I really strongly recommend that this weekend you use some of your free time, which we all will have some, to continue studying for the final exam. Thanks for tuning in, Titans. I appreciate it.